The new thing that we need to talk about before our mini test is solving radicals. Function operations is something we'll do in the next half, okay? So function operations is later. We'll do that after the mini test. Today we got to talk about solving radical equations. So we've been talking about simplifying radicals. We've been talking about combining radicals. Now we got to talk about what happens when you're solving an equation that has a radical involved in it. So let's just dive right in here with an example. Solving radical equations. Let's do it. It says solve for x, and then check your solution. I have the negative square root of 5x plus 1 minus 6 equals negative 10. Terrific. Yep. All right, so think back to when we were solving equations that had a power in them, like an exponent. Remember, in order to solve those, the goal was we had to get the thing being raised to a power all by itself, so that then you could like take a square root and get rid of it. This is very similar, all right? So kind of your first goal when you see a problem like this, you need to isolate the radical. And remember, the radical is a fancy word for the root sign. So wherever the radical is, I need to get that thing by itself on one side of the equation, and then I'll be able to get rid of it, okay? So I got a radical right here. That means I need to get this thing all by itself, okay? So what can I do first? What can I get rid of? Okay, so I can add 6. That'll be gone. I have negative square root of 5x plus 1 equals negative 4. Cool. Is the radical by itself?
Yeah.
Almost. There's a negative. I want to get rid of that too. So how do you get rid of a negative? Either way, you can either think of it as multiplying by negative 1, dividing by negative 1, doesn't matter. It accomplishes the same thing. So let's say, oh boy, why does that always happen? Let's say we divide by negative 1. That would get rid of the negative, so now I have square root of 5x plus 1 equals what? Positive 4. All right, so far so good? Okay, square root is now alone. It's isolated. The radical is isolated. So I have the square root of something. I want to now get rid of the square root. If I want to get rid of a square root, how do I undo it? Square it. Just do the opposite of it. I'm going to have to... I don't get how this thing works. Yeah, but this is the pen side. I don't usually use this side because it makes a weird noise. Whatever. So I got to square it, and if I square it, the square root's going to go away, okay? Whatever you do to one side, you got to do to the other. So now the square root's gone. I have 5x plus 1. Notice how the numbers don't change. I'm not like squaring those numbers because they're inside a square root. And if I square it, the square root's gone, and we're good, okay? What's 4 squared? All right, do you think you can solve that? Yeah, what would you do? Subtract 1, divide 5, and you ascertain that x equals 3. Yes? Terrific. Does that process make a little bit of sense? All right, it says check your solution. Do you know how to check a solution? You just plug it back in. We haven't talked about checking solutions a ton in this class, but on this thing in particular, we're going to have to do it a lot, and I'll show you why here in a minute. But for now, check your solution. That means plug this, x equals 3, back into the initial equation. So we have negative square root of 5 times 3 plus 1 equal, or sorry, minus 6 equals negative 10. So what we're trying to determine is, does that work? Well, I'm going to have negative square root of 15 plus 1 minus 6 equals negative 10. Because this pen doesn't work, okay? What is this going to be? It's going to be 16, right? What's the square root of 16? But it's negative, so it's negative 4. Oh, we're having a rough day. We got negative 4 minus 6. What's negative 4 minus 6? Oh, so we're rocking and rolling. Yeah? This turned into a 16, and the square root of 16 is 4, right? But there was a negative in front of it, so it's negative 4. Okay? So I checked it. We're good to go. All right, listen up, guys. Listen to me. I'm going to have you try this one on your own, but what's different between this one and the one we just did? This is a cube root. How do you get rid of a cube root? You're going to raise it to the power of 3. But before you do that, remember, you got to get it alone first, okay? So give this one a try. Ready, set, go. Here we go. We are going to solve this. So I got to get the radical alone. What do you want to do first? Minus the 3. What's going on here? Minus 3. All right. So I'm going to have square root of 5x minus 1 equals x minus 3. Yes? All right. That's easy enough. How do you get rid of the square root? You square it. So I got to square both sides. Okay? So we got to think about what this is going to look like. I'm going to have 5x minus 1 here, because the square root just goes away. This is x minus 3 squared. All right, so I would be willing to bet that if you were doing this problem, probably the majority of us got to this point and did this and said this is x squared minus 9. I bet a lot of us did that. You cannot do that. You cannot distribute the exponent, right? Unless this is all one piece. But it's not one piece, it's 2 pieces. So, what is x minus 3 squared? What is it technically? It's x minus 3 times x minus 3. It is this, x minus 3 times x minus 3. And how do you do that? You got to double distribute, right? X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is another negative 3x. Negative 3 times negative 3 is positive 9. Do you remember doing double distributing? We've done it a lot. We've done it a lot. Can you do anything with this? Can you simplify this? Yeah, you can put these together, right? It's going to be minus 6x plus 9, because negative 3 at negative 3 is negative 6. Okay? All right, so now you might be thinking, well, Mr. Smith, that's great, but that still looks gross. Well, there's a lot of x's running around, but here's the pro tip I'm going to give you. Let me ask you a question. What does this look like? Looks like a quadratic, right? So here it is. Here's the pro tip. When it's starting to look like a quadratic, it probably is going to be a quadratic. So what you need to try to do is get everything on the same side. Get everything on one side so it turns into a quadratic, okay? It looks quadratic. So get everything on the same side. All right, here's another pro tip. Here's another pro tip. I would like to avoid x squared becoming negative. I don't want this to become negative. So instead of subtracting this over here, I'm going to move this stuff over here. So I got to subtract 5x. I got to add 1. It's going to look like this. X squared negative 6x minus 5x is negative 11x. 9 plus 1 is 10. Are you guys okay with what I just did? Do you see how I went from here to here? Okay. And again, the reason for that is that I don't want this to become negative. So I'm going to keep it where it is, and I'm going to move everything else. Okay? All right, now, this is quadratic. Okay, so throw back to last quarter. We're trying to solve this, right? What are the methods you have to solve a quadratic? We did 4 of them. Okay, you can do quad formula. What else can you do? Factor. What else can you do? You can do completing the square, and what else can you do? There's one more. Square roots. Those are the 4 options. I know immediately that I can't do square roots. Why can't I do square roots? There's more than one x. Can't do square roots. Okay? All right, so you could try any of these. Which one do you think is probably the easiest? Factoring. If you can factor, factoring is the easiest. So let's try to factor it, see what happens. X squared minus 11x plus 10. I'm trying to factor that. A times C. What's A? 1. So I need 2 things that multiply to 10 and add to negative 11. Negative 1, negative 10. Negative 1 times negative 10 is positive 10. Negative 1 plus negative 10 is negative 11. Boom. Got it. What do you know you can do because A is 1? Yep. You can do the shortcut. You don't need to do the whole big grouping thing. Since A is 1, I can just have x minus 1 and x minus 10. All right, so cool. It's factored. Oh, hello. How you doing, Mr. Knierim? All right, guys, listen up, listen up. Let's finish this out. Listen up, listen up. Do you remember how to solve this now? Yep, you split them up. You set both pieces equal to 0. Okay, so I get x equals 1. I get x equals 10. Beautiful. If you want to do quad formula, do quad formula. It's fine. Remember, you can always do quad formula. Yep. All right, hey. Because I feel like I'm yelling at the top of my lungs today. Can you guys be a little bit more quiet for me? Thank you. Do you have any questions on anything that we did here? Yeah, we will. We will. So remember, well, just two quick things. Pro tip. Remember, if it's starting to look like a quadratic, get everything on the same side, and then you're just solving it. For sake of time, normally you would have to plug both of these in and check them. For sake of time, we're not going to do that right now because I got something else to show you, and then you're going to practice for a little bit. Okay? So there's some words up there. It says raising each side of the equation to a power may introduce solutions that are not solutions to the original equation. So here's what that means. If you like square your problem or raise it to a third root like we did here, like you have to square this, right? If you do this, it's kind of like the opposite of the plus minus. Remember, we had to add the plus minus to account for a negative that might show up. This is kind of the opposite. If you're squaring it, you might introduce a solution into the system that's not actually a solution, all right? And in that event, we call those things, if you get a solution that is not actually a solution, we call that an extraneous solution. An extraneous solution is just a solution that doesn't exist. It's an imposter. Well, you'll find out when you check them. That's why we have to check them. Because if you get an answer and you check it, one of them might work, one of them might not. So the one that doesn't work is your extraneous solution. The one that does work is good to go. Okay, so you won't always. Yeah. There's really not a difference. The difference is that an extraneous solution, unless you check it, you're going to think it is a solution. No, it doesn't mean you did it wrong. It means you did it right. You just get a solution that doesn't actually work. Okay? So you might have an imposter and you need to figure out who the imposter is. Someone should make a game about that. Make a lot of money. All right. Do you want to do this together or try it on your own? Yeah, let's just get through it together and then you're going to do some on your own. Okay? So I'm going to solve it and then I got to check. So hang with me for just a little bit longer, guys. This is the last time I'm going to talk to you today. Just hang with me. Is the radical alone? Yes. So I'm going to square. It's going to be 2x plus 7 equals, I got to do x minus 4 squared. X minus 4 times x minus 4. Double distribute. That's x squared minus 4x plus 16. You can simplify that a little bit more. X squared minus 8x plus 16.
Wait, where do you get the minus 4x?
X times negative 4 is negative 4x, and then negative 4 times x is negative, yeah. Negative 4 times negative 4 is positive 16. Okay? We all right with that? I know I went through the double distributing kind of quick. Okay, what is it starting to look like? Quadratic. So that is a signal that you need to get everything on the same side. I like to keep this positive, so I'm not going to move it. I'm going to move everything else over here. I got to subtract 2x. I need to subtract 7. 0 equals x squared. Negative 8x minus 2x is what? Negative 10x. And 16 minus 7 is 9. Yeah? So I subtracted 2x here, and I subtracted 7 here. So far, so good? All right. So now it's a quadratic. Factor, quadratic formula, complete the square, but you can't do square roots. You can do any of the other ones. So if you want to do quad formula, when in doubt, do quad formula. It'll always work. I like to factor. Two things that multiply to 9 and add to negative 10. Negative 9 and negative 1. A is 1, so I can put them in the parentheses. I have 0 equals x minus 9, x minus 1, yes? I know we're kind of moving quick here. Are you guys tracking with me? What do I do now? Double distribution would get me right back to here. So I'm trying to solve them, right? So I'm going to split them up, set them both equal to 0. So I get 9 and I get 1. Okay, so those are the two solutions I get. But here's the deal. Because I squared stuff at the beginning, that might introduce a solution that doesn't actually work for my initial equation. So what I need to do is check both of these to determine if one of them is extraneous, aka an imposter. All right. So let's just do one at a time. I got 9 and I got 1. We'll do the check over here. So let's do x equals 9 first. I'm taking 9, I'm plugging it into my original thing. Square root of 2 times 9 plus 7 equals 7 minus 4. I'm just trying to see if that works. Okay? So let's see what we get. What's 2 times 9? Oh, sorry. 9 right here. All right, so this is 2 times 9, 18. 18 plus 7 is 25, right? So square root of 25 equals 9 minus 4. What's the square root of 25? And what's 9 minus 4? Yeah. You do not use the plus minus here because the square root was already there. I'm not adding it in. So the only time you get a plus minus is if you are the one to take the square root, like you introduce it to the equation. Then it doesn't work. It doesn't. Yeah, you just take the positive. Yeah. Okay, 5 minus 5, that's good. So that means that 9 works. 9 is good, okay? We can't just conclude that 1 is the imposter. Innocent till proven guilty, right? That's how the United States of America works. You're innocent until proven guilty. So we need to check x equals 1. Let's put x equals 1 on trial. See what happens. You gonna vote? Do you think it's an imposter? No? Okay. You already know. You have insider information. All right, so again, I'm plugging in 1 for x. 2 times 1 is 1. Or sorry, 2 times 1 is 2. Plus 7 is 9. What's the square root of 9? 3. What's 1 minus 4? Okay, are those the same number? No. So that means that 1 is extraneous. 1 is an extraneous solution. It doesn't actually work. So the only true solution here is 9. Yeah. Most of the time, but it just depends. You just got to check. No. Yes. No, this is it. Yeah. What do you mean? Like here? No. You only take the positive. And again, the reason for that is that when we add the plus minus, that's if you're solving this, you would say, oh, you need to take a square root. Well, the square root's not there. I'm adding it in. If the square root's already there, I'm not introducing it to the equation. So there's no chance of like an extra negative getting in there. That's why we need to add the plus minus here. But since it's already there, we don't need to account for that. Okay. All right.